Okay, welcome everybody. Today we're going to be starting our new unit, which is stoichiometry. And we kind of did a little bit with this a while ago with the moles and the molar mass. So I'm hoping that that preparation will serve us well for what we're about ready to do. So what we're going to do is split this video into two. The first video is going to just review what the formula mass is one more time. And then we're going to discuss something a little bit on the new side, which is the percent composition of a compound. When we do these two things, we will follow both up with an activity and a little lab. After this, we will be getting into empirical formulas and molecular formulas, and then it just kind of goes on from there. So let's get started with this first standard, which is calculating formula mass to the hundredths place, followed with the next part, which is going to be finding percent composition of a compound. Okay, so this first idea, I want to make sure that we go back in time a little bit about the mole. And if you recall correctly, the mole is just how we count things in chemistry. Okay, so the mole is equal to the average atomic mass of something. And so that's going to help us whenever we're getting our formula mass of something. So as you recall, if we wanted to get this down to the particle level, which would be like atoms or molecules, then we would know that 1 mole would be equal to Avogadro's constant, which is 6.02 times 10 to the 23rd particles. Mostly, though, in stoichiometry, we will be using higher numbers, which is going to be getting the grams to the moles, because we're going to be looking at things basically in the laboratory. And yes, you will be having a lot more laboratory experience this time around. Okay, so this is just a way that we quantify a number. It's sort of like the word dozen out in the real world. We just use moles here in chemistry. So you can say all these substances above are equivalent to 1 mole of that substance. So here's 1 mole of, let's say, these little nails here, 1 mole sulfur, etc. Okay, so don't let this word confuse you. It's nothing that dramatic. It's just a word we use for helping us to quantify things in chemistry. So we're going to take that one step further and apply this to the molar mass. And we did go over this before, but I wanted to make sure I brought this back to your attention to get it into the front part of your brain. So the molar mass of any substance is equal to the mass, that's in grams, of 1 mole of a substance. And remember, we need your periodic table for this information. Okay, so that periodic table is going to be your best friend, or of course you can use EMD on your, your tablet here. The EMD, I also noticed if you go over here to the M, oops, let's get it actually on here. And if you go down to atomic properties, there's a molar mass calculator, which is also nice. I had you download one a while ago, but this is a nice one-stop shopping. It has the EMD, it has all of the properties, and it also has the molar mass. So we can use this, or of course you can use your handy-dandy periodic table. Just make sure you have one of them ready and your calculator, because you will be needing those all of Unit 7. So when you get to class, the first things you should be bringing out is your calculator and your periodic table. Okay, there's no getting away with this anymore. Okay, so let's look at this. I want to know what the molar mass of water is. And if you're wondering what this big M, a little r is, this is how they do it in the IB world. Okay, so it just means the relative molecular mass. They put a big M with an R as a subscript. So let's just look at the molar mass of water. Recall that we have 2 moles of hydrogen, or 2 atoms of hydrogen, and we have 1 mole or 1 atom of oxygen. So let's go and take a look at this. So we have a mass of 2 moles of hydrogen. We would take 2 times, and we will look on our periodic table and look at the number at the bottom for the 1.01. Multiply those two, and we would get 2.016 grams. Now, our standards wants us to round things to the hundredths place, so make sure you're keeping that in mind. So we're going to just, make this 2.02 down the road, and then make sure your final answer has it to 2 places as well, to the hundredths place. So we had the mass of 1 mole of oxygen is 1 times 16. If you look in our periodic table, it's 15.99. After we add those two together, we get 18.02 grams of water. Okay, that's how many grams are in 1 mole of water. Okay, and this is just a visual interpretation of it. So if you have, let's say, 1 mole of SO2 molecules, that means that we have 1 mole of S atoms and we have 2 moles of O atoms. Notice how I'm starting to integrate this terminology into our playing field here. Okay. Okay, so let's go ahead and do some little practice problems here. So what is the mass of 1 mole of methane? Well, always start with your given, if you recall. It gives us 1 mole of methane. Okay, so we have 1 mole, MOL, and we have CH4. And we need to go and determine the molar mass of this compound. So we're going to put our moles down here at the bottom of methane because we know we want those to cancel. And I need something over here in grams of CH4. Okay, so we're going to have to go and calculate this. So if we look and see 1 mole of carbon on our periodic table, if you look over here, is 12.01. Okay, so we're just going to put that down here. It's 12.01. And we have 4 moles of hydrogen. Okay, and we know that that's 4 times 1.01. We just look on our periodic table. Okay, let's go ahead and get our calculator out here. So we have 12.01 plus 4.04 gives us 16.05. Okay, so 16.05 grams. Notice that's what's left behind because these moles are out of here. Okay, they cancel out. We're just left here with grams. So 16.05 grams of CH4. I'll put that over here. Now we just simply finish up the math. 1 times 16.05 is equal to just 16.05. So that's your final answer. In grams. We got rid of the moles. Okay, I really should get my pen. This mouse is not working too well. Okay, so you might be wondering, well, Miss N, how do I get this? Well, you know how to do this because we've just been naming compounds to death. Okay, so we need to go and find calcium carbonate. So look on the back of your periodic table if you need to. Remember, I gave you all of these. So carbonate is, let's see, where are you? You're found there from the 2- thing here. And if you recall, it's CO3. Okay, so we're going to put these two together. Calcium carbonate. And we start with 1 mole because that's what it's asking us to do. Okay, and then we're going to go and calculate all of these. So again, you're going to take 1 mole of calcium plus 1 mole of the carbon and 3 moles of oxygen and add all of those up. So calcium, if you look on your periodic table, is 40.08. And then we know that carbon, if you don't have this memorized by now, you will, is 12.01. And then we have 3 times 16 basically for our oxygen. Let's go find out what all this is. 40.08, 0.01, 100.09 grams of CaCO3. Okay, so these aren't too hard. Hopefully you remember these and that's back into your brains. Okay, this is something maybe a little bit on the newer side, and we're going to follow this up with an M&M activity. We're going to deal with percent composition, so I wanted to first give you an example with the mass of M&Ms and then relate it to chemistry. So let's just say I give you a little cup of M&Ms, or if you took a bag of M&Ms and you counted out all of the red ones. So inside of 1 bag of red M&Ms, there might have been 200 M&Ms altogether, and you found that there were 26 that were red. So you're just going to use this formula with percent composition. You take the mass of the sample, and then you're going to take the total mass of the sample, and then you're going to multiply that by 100%. Okay, so for this particular example, we didn't really actually have a mass. We're just going to go by the colors of the M&Ms. So we had 26 that were red, and we had 200 in total. Multiply that by 100. That means that 13% were red in the bag. Okay, not too hard. You've probably been doing this since 5th grade math. Okay, so let's relate this information to chemistry. Let's say you had to find the percent composition of just copper in this entire compound, copper bromide. So what you want to do is, first of all, go in your periodic table and locate copper. Okay, and copper is right here, and you'll see that it's 63.55. Okay, so you're going to take that information, that is the actual mass of that particular sample of just copper, and you're going to put that over the molar mass of the entire compound. So that's why we have to first find this entire molar mass of copper bromide, so that you know what you're going to be doing here. Okay, and there's 2 bromides. So make sure you're doing that first. And then if you do that correctly, you should come up with about 223.354 grams. Multiply that by 100 and you come up with 28.4%. That's how many percentage points are actually sitting here of copper in this entire compound. Okay, so you can see that it's mostly made up of bromine. Okay, now we will pause to conduct a percent composition activity using our M&Ms. And you will be going into the lab next time I see you to do a percent composition lab with some hydrated copper sulfate. We're going to actually not hydrate it anymore, okay? So take a pause and do those, and then we will continue on with the empirical formula. Now, just in case you get further than the lab and you're ready for this, just move on to video 2 and learn about the empirical formula versus molecular formula, and you can start doing a few worksheets that have to do with that. And just know that that is also followed up by labs. So you have 2 labs coming up here in the next couple weeks. Alrighty, that's all for now. See you in a little bit.